in just 11 minutes. Let's go through the process of implementing Smart Wallet as a Service within an application built on Combo. Combo Network exists for the sole purpose of solving some of the longest standing issues preventing strong consumer-friendly Web3 games from being produced. So things like lacking scalability, high transaction costs, limited tooling, and so on. Combo specifically is a layer 2, centered around providing the infrastructure for next generation Web3 games to be created. Combo is building an open ecosystem in which developers can create games that are efficient and have a very low barrier to entry. And a big part of this tech stack for game developers is actually Wallet as a Service. Games require very familiar and accessible user experience. So things like frequent signatures, complicated wallet creation, and so on can really reduce the potential for games. So this is why we brought our Smart Wallet as a Service natively to Combo to enable game developers to build games leveraging things like account abstraction for session keys and gasless transactions, and of course Wallet as a Service to introduce seedless onboarding through social logins. So today, in just 11 minutes, I want to go through step by step how you can create an application on Combo that leverages Smart Wallet as a Service to onboard users and send a gasless transaction. Then you can take this flow and concept and apply it to your own game that you might be building on Combo. So the application we're going to be building today is going to be separated into two halves. The first will be index.tsx. Index is going to act as our sort of configuration file in which we can configure Particle Network and initialize the SDK. From there, we'll write app.tsx. This will contain all of our key functions, and in this example, that'll include fetching the user's balance, signing them in through either their Google or Twitter account, assigning a smart account, and then executing a sample user operation. So let's go ahead and kick it off with index.tsx. Like I mentioned, we're going to be using this file for configuration. So let's begin by importing a few different required libraries. We can begin with React, along with React DOM. And then on the particle side, we can import combo testnet from @particle-network/chains. And then additionally, we can import authcore context provider from @particle-network/authcore modal. Now, authcore context provider is going to be our primary configuration object that we can use to initialize particle auth. So let's go ahead and close this out by importing our app component from ./app. So now to actually specify the parameters within authcore context provider, let's begin by doing react dom.create root and then pass in document get element by ID, which itself will take root. And then we can cast that as type HTML element, then call .render. Now within here, we can begin by opening up a react.strict mode tag and then opening authcore context provider. And now within here, we can define options. Within options, we'll need to specify all of our different configurations, starting with 3 required values. This will be our project ID, our client key, and our app ID. These 3 values are required within every Particle SDK because they fundamentally connect this application to the Particle dashboard. So let's head over to the Particle dashboard and create a new project to retrieve these values. All right, so as you can see, I am now on the Particle dashboard. I can go and click on Add New Project and name this Combo Demo, then click Save. Now within here, there's a lot of options. You can, of course, check your application activity, customize the authentication modal, access the paymaster and bundler docs, even spin up RPC endpoints. But in this case, let's stick to the applications menu and spin up an application. That'll be a web app, and I'll again name this Combo Demo. And then within the domain field, I can throw in the domain in which I'm hosting the application. Although if you're running this locally, then don't worry, feel free to throw in any filler domain and it'll still work. And then go ahead and click on OK. And here we go. So let's now copy our project ID, our client key, and our app ID. Then we can go ahead and throw those into environment variables and continue. Let's begin by defining the project ID as process.env.react app project ID. And we can do the same thing for client key along with app ID. Okay, so now with those established, we now need to define 2 optional parameters. The first of which will be ERC437. Within ERC437, we need to define the specific type of smart account that we'll be using within the application. At the moment, we support Combo through simple account, so we can set the name to simple and the version to 1.0.0. Then next, we can set the wallet parameter. And within wallet, we can basically control whether or not the wallet modal will pop up after login or not. So basically, after a user logs in, we have the option of displaying the little particle logo on the bottom right of the application, which will open up a full wallet interface if the user clicks it. This gives users a sort of central place to access and manage their wallet, so we can determine if that displays or not with visible, and in my case, I'll set that to true. Now, because I'm setting visible to true, I can also define custom style, and then within here, I can throw in support chains, which will take combo testnet. This will basically just ensure that once the wallet modal does display, the only chain available within the modal is the combo testnet. And then we can go and close it off here by throwing in our app component. And there we go. We've imported all of our base libraries and configured Particle Network through authcore context provider. So let's now move on to app.tsx. Like I mentioned, this is the main file within our application that we'll be using to define the logic powering this demo. So once again, similar to index, let's begin by importing a few different required libraries. The first will be React, and specifically use state and use effect. Then from particle, we can import 3 different hooks: use Ethereum, use connect, and use auth core. That'll be from @particle-network/auth core modal. Additionally, just like index, we can also import combo testnet from @particle-network/chains. And then on the account abstraction side, let's also import a wrap provider, smart account, and send transaction mode. That'll be from @particle-network/a. Then finally, we can import ethers as well as notification from NT. Then to close it off, let's also import our CSS. And perfect. Let's now define our primary app component. We can just simply call this app. And to begin with an app, we need to define functions derived from the 3 hooks that we imported along with one state. So let's begin with the 3 hooks. The first will be provider from use Ethereum, as well as connect and disconnect from use connect. And then additionally, we can also do user info from use auth core. And then like I mentioned, we also need to define one state. In this case, it'll be balance, and set balance as use state. Okay, so now with this defined, we need to go ahead and initialize our smart account. This is a very important part of the application where we basically need to decide formally what type of smart account we want to assign the EOA generated by social login. Like I mentioned prior, we're going to be using a simple account. So let's define this within smart account and set that equal to new smart account. That will take provider as well as this object here. Now within here, similar to auth core context provider, we also need to define our project ID, our client key, along with our app ID. Okay, now to define simple account, we need to go ahead and open up a options, which will take simple, although we also support Biconomy and CyberConnect, but in this case, we'll be sticking with simple as it's the only smart account that we currently support combo on. And then within simple, we can set the chain ID to combo testnet.id and the version to 1.0.0. So smart account in this case is actually going to be used primarily within a custom ethers provider so that we can send transactions through the smart. Because typically whenever you send a transaction with ethers, it's formatted as an EOA transaction, which is different than user operations within ERC 457 account abstraction. So thus we need to create a custom ethers provider to ensure that our functionality stays consistent with the fact that we're using account abstraction. So let's do that within custom provider. That'll be new ethers.providers.web3 provider. And that'll take new a wrap provider, which itself will take smart account, as well as send transaction mode.gasless. By setting send transaction mode.gasless here, we are basically telling the SDK to route all transactions through this provider as gasless. Now, because we're on the testnet, these will be automatically sponsored for free, and thus the user here will pay no gas. Then let's also throw in any. All right, so now with our sort of initial boring stuff out of the way, let's go ahead and create the 3 core functionalities of this application. The first will be balance retrieval. Then we'll need to handle social login, and finally execute that sample user operation that I mentioned earlier. So let's begin with balance retrieval. We can start by opening up a use effect. And within here, we need to check the condition of user info, which is basically checking if a user has logged in or not. Because if user info is not defined or a falsy value, then a user has not logged in. Or if it is defined, then a user has logged in. So in this case, we only want to fetch the balance once a user has logged in, and thus if they have, we can call fetch balance. Now fetch balance isn't yet defined, but we'll be defining that right now. Although let's quickly make this use effect dependent upon the status of user info. So let's now go ahead and write fetch balance. That'll be asynchronous. And now we can do fetch balance in basically 3 lines of code. First, we'll be retrieving the smart account address through address and await smart account.get address. Then we can define balance response to retrieve the balance with await custom provider.get balance, and then pass in address. Now finally, we can take the balance response and set the balance state with set balance, although by default, balance response will be in a way format, which isn't very readable. So let's convert it with ethers.utils format ether, and then pass in balance response. Okay, so that's our balance logic complete. Let's now move on to defining our logic for handling social login. We can call this handle login. That'll also be asynchronous and take one parameter called auth type. Now, like I mentioned, handle login is going to contain the logic that powers the ability for users to sign in and create an account with either their Google or Twitter. So let's begin by once again checking the condition of user info, although in this case we want to check if a user has not logged in, because if they have, then this function shouldn't be called. So if they haven't, meaning user info is not defined, then we can call await connect, then set the social type as auth type and the chain as combo testnet. And that's it. That's our entire logic for handle login. So let's now cover the final function within the application. This will be execute user op. And now the goal here will be to send a transaction that is a burn of 0.001 BNB. So basically, we'll just be sending a sample transaction to a data address of 0.001 BNB. So let's begin by first retrieving the signer within custom provider.get signer. Now we can go ahead and construct our transaction within TX. This will just simply take 2 parameters, the first being 2. Now within 2, I will throw in this data address right here, which by sending to it will effectively burn the tokens. Then I can also define value as ethers.utils.parse ether, and then throw in the value of 0.001. Okay, so now I want to send that transaction within TX response and do await signer.send transaction and then pass in TX. Now I also want to show the user the transaction receipt or the transaction hash. So let me pull that with TX receipt and set that to TX response.wait. Then I can throw a notification.success and setting the message as TX receipt transaction hash. And that's it. We've imported all of our base libraries, configured the smart account, fetched the user's balance, handled social login, and executed a sample user operation. Let's now format and structure all of this within our JSX by opening up a return statement. Although if you've seen any of these videos before, then you probably know that I usually skip this part because it can take some time and it's quite repetitive. So I'm going to go and get this written and then come back. And here we go. So I'm checking the condition of user info. If once again user info is not defined, then I'm displaying the two login buttons, either sign in with Google or sign in with X, which are both mapped to handle login. Then once they are logged in, I'm displaying their name, their balance in BNB, as well as two buttons, execute user operation and log out. Now log out is simply mapped to disconnect, which we defined from the useConnect hook right here. So let's go ahead and wrap this up by throwing an export default and an app. So it looks like our application is complete. Let's go ahead and run it and see if it works. Looks like it's working. We have our two buttons, sign in with Google and sign in with X. So let's go and give the application a try by signing in with Google. Then I'll go ahead and select this account right here. And here we go. We have my name, my balance in BNB, which is currently 8, our two buttons, and of course the particle wallet pop-up right here, which also displays my balance in BNB. So let's go ahead and give it a try by clicking execute user operation. And as you can see, we have the confirmation pop-up right here. I'll go ahead and click on confirm. And here we go. Let's go ahead and copy this and head over to the Explorer. As you can see, it looks like it was successful. We have the transfer of 0.001 BNB from my address to this address. And of course, the gas fee was also sponsored. Building your game on Combo is a really good choice for a number of reasons, from its speed to its low fees to its ecosystem of game development tools, one of which being Particle's smart wallet as a service. We're really excited to be supporting Combo and the ecosystem of awesome games being built on it. If you'd like to learn a little bit more about Particle Network and our tech stack, including our smart wallet as a service, our intent fusion protocol, our confidential ZK stack, and so on, then I'll have an article detailing all of this linked below. Additionally, if you'd like to try the demo that we made today, or if you'd like to try our main web demo, then I'll also have both of those linked below.